We have two examples left to do in 2.7. That is examples 3 and 4. Now, if you look back up to 1 and 2, in both those cases, we were starting off by multiplying to get rid of denominators, yes?
No.
We want to do the same thing.
Okay.
Okay? We want to multiply to get rid of denominators. In number 1, we just had one denominator x, so we multiplied by x, yes?
Mm-hmm.
In number 2, we had one denominator, x minus 4, so we multiplied by x minus 4. In number 3, what's going on here?
We have two denominators.
We have a denominator of x minus 1, we have a denominator of x minus 3, and technically we have a denominator of x squared minus 4x plus 3.
3.
What about x squared minus 4x plus 3? Is there a connection to the other two denominators?
Yeah.
Does it, yeah, if we factor this, x and x, 3 and 1, negative, negative, it's the same thing, isn't it?
Mm-hmm.
It's that x minus 3 and x minus 1. So, last ones we had one denominator we multiplied by. Now we're going to have two denominators. If we multiply by x minus 1, x minus 3, does that take care of everything? And it does.
Yes.
Okay? So we're going to multiply both sides of our equation by x minus 3 and x minus 1. Now, with the first fraction, x minus 3, x minus 1 over 1 times 2x over x minus 1. What happens on the first fraction?
Well, are we multiplying everything, or just like the 2x minus 1, and then?
One fraction at a time here.
That's what I'm saying. Like, we're doing the 2x over x minus 1 times x minus 3.
So that
Right.
x minus 1s would cancel out, but then you have 2x times x minus
Okay.
3.
So on this first fraction, and I'm not writing it in front of each one, but this x minus 3, x minus 1, it's going to multiply by both this first fraction and eventually the second fraction, right? Okay. But for right now, just multiplying by the first fraction, in this case, the x minus 1s are going to cancel. You're going to be left with the 2x from up here and the x minus 3 from there. Plus, and I'll multiply that out in my next step. Now look at the second fraction. The 1 over x minus 3, we're multiplying it again by x minus 3, x minus 1 over 1. What happens this time?
X minus 3 cancels.
X minus 3 cancels, and officially you're left with
X minus 1, or 1 times x minus 1.
x minus 1, I agree. But it's 1 times x minus 1 if you know, it's those two pieces.
Equals 2.
Equals, what happens on the right?
Everything cancels except for
Yeah, x minus 3 cancels with x minus 3, x minus 1 cancels with x minus 1, so we're left with
x equals
2. Okay. On the left, we can
2.
distribute. So 2x times x minus 6x plus x minus 1 equals 2. Now what?
Combine like terms right there.
Combine like terms. So 2x squared minus 6x plus x is going to be minus 5x. What else is going to happen?
That 2 is going to have to come over.
The 2 is going to have to come over, right? You guys see the quadratic in the making. We're going to also make this equal to 0. So I'm going to subtract the 2 over, and that becomes minus 3.
Yep.
Okay, what are options?
Product of AC.
Okay, product of AC or slip and slide, yes?
Mm-hmm.
And it does work this time. We don't have to go quadratic formula. Technically, could you go quadratic formula?
I'm never doing it.
You could.
You could.
I'm never doing it.
Why would I?
I've never, voluntarily? No. That's
I don't know. Okay,
voluntarily running a suicide down and back.
if we're doing a product of AC, what do I need a product of?
A times C.
So,
Sorry, negative 6.
2 times negative 3, which is negative 6. And I'm going to need a sum of
Negative hat.
negative 5. How can we make this work? Multiplying to be -6 and adding to be -5.
3 and 2, those are numbers, right? No. Yes?
No.
No. 6 and 1.
It's got to be the 6-1 combo.
Yeah,
-6 plus 1.
that would be. He's got it.
Now, what do we do? And I'm going product of AC route. Okay. Take that -6 and that 1 and split your middle term, right?
Yeah.
So 2x squared stays 2x squared.
1.
I'm going to have, what do you want to put?
6.
Either way. Minus 6x plus 1x, still -3, and still equals 0. How do we factor 4 terms often?
Take out the side, cut it in half, and then you take out what you can on each side.
Cut it in half. It's factored by grouping is what the process is called. You're grouping it. What's the GCF of the first two?
2x.
So 2x. 2x squared divided by 2x is x minus 3. GCF of 1x minus 3.
1.
It's just a 1, right? If all else fails, you have to have some type of GCF here. So, and it's going to be a positive 1. You divide x minus 3 by 1, you're still at
X minus 3.
x minus 3. Now, my next step reads as 2 parentheses, yes? 1 parenthesis comes from my
Outsides.
the GCFs. So the 2x plus 1. The other parenthesis comes from my matching parentheses. X minus 3. Set each factor
Equal to 0.
equal to 0.
I found them.
2x plus 1 equals 0. X minus 3 equals 0. Subtract 1. Divide by 2. Add 3. I have answers of -1, half, and 3.
And they work when you put them in the graph.
Yeah, check it graphically.
What graph did you check them on? Because they don't both work.
2x squared minus 5x minus 3.
Well, yeah, they're both going to work on that. You have to use the original.
Yeah, buddy.
You can't use the quadratic there.
We did it yesterday and it worked.
No,
No,
we
no,
used
no.
it to check.
We used it to check something else. You have to go back to the original if you're going to check graphically, which in this case would mean
Wait,
taking that original and making it equal to 0.
yes, you would then subtract
it's
over
gonna be easier
2.
to plug it in.
Now, here, let me give the shortcut here, guys. Okay, the shortcut. Look at your denominators.
3 doesn't work.
Why does 3 not work? Why is it so obvious?
If you plug it into one of them, it makes the denominator 0.
Okay, 3 minus 3 makes this denominator 0. I know for that purpose, 3 cannot work. What else wouldn't work if we had it?
1.
1 wouldn't work. Was it an answer though?
No.
No. So 3 doesn't work because it makes my denominator 0. It would actually make 2 denominators 0 because it would make this other denominator 0 also. So be sure to check. Okay. And my recommendation, if all else fails, check in the denominators. Okay.
It's not being respectful, sir.
Okay. So that's my hint there. That's kind of your short check. Check in the denominators.
So if it doesn't equal 0,
If it doesn't equal 0, it probably works.
we want homework here.
Chili with crackers today.
Okay, guys, one more here. Example 4.
It's equal.
What do I do?
Something.
I've got 3 denominators. I don't like
Factor out.
denominators.
Well, you can factor out
all 3. No, you can't. You can't factor it out. Oh, gosh.
It could be, you can multiply them by x and then x plus 2 because that's
Okay, so we have a denominator of x, and we have a denominator of x plus 2. Those definitely have to be those definitely have to multiply those. What about x squared plus 2x? Yeah, GCF, factor on x, and that is x times x plus 2.
Yeah.
So do I need to multiply by a third piece?
Yeah.
No, because x matches, x plus 2 matches. Okay. What am I going to multiply both sides of my equation by?
X and
X and x plus 2. X
I mean, it's still 0.
and x plus 2.
Can we just take that one out quick? It's 0.
I agree. Doesn't mean I'm not going to write it down.
I'm not gonna write it.
I'm not gonna
it down.
On the left, first fraction. X plus 2 over 1 times x minus 3 over x. What happens?
Your x is gonna cancel. Then you're gonna be doing a bitem. We don't have to divide it.
X is going to cancel. And so I'm going to write down that I'm going to have x plus 2 times x minus 3. And we'll multiply that in the next go round. Plus. Okay, now, same original fraction. This time, it's times the 3 over x plus 2. What happens?
Well, the x plus 2 cancels.
X plus 2 cancels. And what do we have left?
X times 3.
X times 3. Plus.
0. Oh, sorry. 6.
What happens with this third fraction?
Everything.
X cancels.
Cancels.
X plus 2 cancels. We're left with
6.
6. On the right, 0 times anything is 0. Okay, guys. What about x minus 3 times x plus 2? Officially, you need to
Foil.
FOIL.
You're gonna get x squared minus 3x plus 2x minus 6. And then you finish the equation.
Okay, so x squared minus 3x plus 2x minus 6. You still have your plus 3x and your plus 6.
You keep that x squared, and then just combine like terms. So your x or your 6's are gonna cancel actually.
It's just x squared.
Yeah, and then it's plus 2x. Yeah.
And then you factor out.
Okay, are you guys with them? 3x is canceled, 6 is canceled, x squared plus 2x. How do I solve this?
You
Factor out
factor out the x, and so x equals 0 and negative.
Factor out at GCF of x, so you have x times x plus 2. Set each factor equal to 0. So you get x equals 0, and you get x equals
-2.
-2 when you do the math.
Why can't it be negative 10? Huh?
Because negative 2 plus 2 equals 0.
And then
Does it?
we always check. Cannot stress enough to check in this unit. What happens when we check?
Neither will work.
Okay, 0 would make this denominator here 0. And I can't have a denominator of 0, so 0 is gone. -2 makes this denominator here. -2 plus 2 is 0. I can't have that. Nothing worked. So what are we going to say?
No solutions.
No solution. You do see something sometimes, which is a circle with a slash through it, which is the empty set. That's a mathematical way to say no solution. Okay? Okay, guys. You've got the basics. You're going to see some basic equations. You're going to see some tricky equations. So, get working on them.
It's great.
4 through 28 evens.
It's gonna be great. It'll be fun, Vic.